Here we go. We're talking about matrices. Matrices are kind of like octopi. Well, because an octopus is a single little creature with 8 legs. Multiple octopus make octopi. If I had 23 octopuses, I wouldn't say pusses, I'd say pie. So same idea on matrices. That's like a lot of matrices, except you say matrices. A matrix is this little thing right here. It is a rectangular arrangement of numbers, okay, and they can be positive, they can be negative, they can be letters like that A in there. And the important parts I'm going to teach you today are about how each of these little pieces is arranged, like in rows and columns, and like exactly where it is officially, like the name of that spot right here. And I'm also going to teach you how to add matrices and do simple multiplying of matrices, and then the more complicated stuff we'll do tomorrow. So this is kind of the easy day where we just learn what they are. Each little piece is called an element. Okay, so that's an element, that's an element, that's an element, that's an element. So this has 4 elements. And it's got rows and columns. In case you've forgotten, I have a way for you to remember it. Remember the columns, like in a building, they hold up the building, so they go up and down, right? Excuse me. So the columns go up and down here too. So this is column 1, and that's column 2. The rows obviously must go the other way. Row 1, row 2. My thought of that was like when you go to a play or maybe a baseball game. So I linked it to the Twins field, the Target field. How many of you guys have actually been to Target Field already? Yeah. Cool. When you go and if you were in row 1, wouldn't that be a good thing? Yeah, row 1's like right down in the front. Okay. And what if you were in row 1 and like seat 10? It doesn't really matter that much which seat it is because you're in row 1, right? Okay, so that must be the front row. All right. Well, in Twins Field, they do say that this is one of those stadiums where you can get a good view of the game from almost anywhere. Of course, the ones that are right up close, like row 1, right behind the dugout, those are the ones that are most expensive. So this thing seems to not be able to load it. It must be too big of a file today. So anyway, I'll just minimize it. Maybe it'll eventually get it loaded. I can move this little thing around. Okay, so my smart board is fine, but it looks like my computer is frozen. Great! Let's see if I can just kill this thing. I'm going to start by stopping the recording. Okay, so we got that stupid thing shut down. Anyway, rows versus columns are really important. So what I'm going to have you do to make sure you get this idea is to make a 3x3 matrix on your paper. So everybody make a thing like this that's big enough so that you can put 3 numbers across and 3 numbers down. That'll make a total of 9 little spots. And what I want you to do is label them like this. That spot right there would be row 1, column 1. What would the spot right underneath it be? Row 2, column 1. And then row 3, column 1. And then you go to the middle, which would not be column 1 anymore. So it would be what? Row what? 1, column 2. Can you finish this? Okay, on your paper. Make sure you're getting which ones are rows, which ones are columns. It's crucial because that's the hard part when you get to multiplying them, is understanding where in the matrix you are. If we need to get to like row 3, column 1, you got to be able to find it. I've got a little clip of the matrix in here. All right, so if you didn't already know this, it would be row 2, column 2, row 3, column 2. And if you notice, see how this stays the same? Column 1, column 1, column 1? Same column 2, column 2, column 2. So this is column 3, column 3, column 3. And then you can just go through and say row 1, row 2, row 3. All right, there it is. How many of you had it right? Okay. Then the matrix. this is kind of a classic scene from a movie that was done a long time ago. Hold on just a second. Let me see if I can get the sound going on this thing. Was it 2005? I can believe that. I don't know. It was a while ago. Let me see if I can get the sound. Why isn't the sound working? Man, this is one of those days. All right. Okay, the movie The Matrix. You see how he's like dodging the bullets? Yep, you got hit. And the bad guy comes up, and it gets scary, so I can't show it to you. But anyway, I did find a clip where somebody showed how you can make one of those kind of scenes. Just watch quick. There's a guy, and he's recording. All right, I'll make it bigger. He's going to just show you how to record yourself. And then you record the first one, and you also have it, if you have the video effect of being able to like have it follow like that, then all four of them put together makes it look like you're doing this kind of crazy thing all at insane speeds. And then there's this guy, which I watched last hour. It's pretty amazing. Look at this. Whoop. He can just stand up and then go back down. Go back up again. He's seriously doing this. Okay, anyway. Get done with that. Okay. All right, moving on. So, this matrix is 2 by 3. You have to be able to look at them and say whether they're 3 by 2 or 2 by 3. And here's the thing you got to remember. It's rows then columns. Everybody write down RC at the top of your page. It is so easy to get that confused. If you start doing columns and then rows, it'll mess everything up. It's always rows first and then columns. RC. So look at this and tell me, do you see that it has 2 rows? And then do you see that it has 3 columns? So this is a 2 by 3 matrix. So what's this? The first thing you ask yourself is how many rows does it have? 4 rows, 3 columns. It's a 4 by 3. That's a 4 by 3 matrix. Get that? All right. Next one, how many rows? So it's 4 by 2. The next one, how many rows? 2. So it's 2 by 4. How many rows on this one? So it's 3 by 2. If the matrix has the same number of rows as columns, then it's said to be a square matrix. Now this one looks like a rectangle to me, but it's square. Why? Because it's the same number of rows and columns. Okay? So it's 3 by 3. So that's a square matrix. All right, moving on. That top left one, what is it? A what by what? 2 by 2. What's this one? How many rows? 1. So it's 1 by 3. How many rows in this one? So it's 2 by 3. All right. Moving on. Anytime you have your data arranged in any kind of a rectangle, like any rows and columns, then you've got a matrix. Like a seating chart is a matrix. So right now you are in the matrix. A month, like calendar. Okay, a calendar is a matrix. Calendar is like a whole bunch of, like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then it goes all the way down until the end of the month, right? That's a big matrix. The only thing is on a calendar, when you have an empty spot at the end of the calendar, you usually don't write anything in there. Maybe sometimes they have like the next month started and they like write them in faded letters. Like at the very end of the calendar when there's an extra few boxes, they leave them blank. But we with a matrix never leave a spot blank. So like you'd never see a matrix that goes 2, 3, and a 5 here and leave this empty. There has to be something there. And if there's nothing there, what do you think they put? A 0. If there's nothing there, you put a 0. If there is a variable, like that implies that you could put multiple things in there. All right, that means that I could put anything I want in there. That's different than 0. 0 is a value just like any other number. All right, now if I wanted to put a 5 outside here, take a guess what you think would happen. Times everything by 5. And your answer would end up coming out to be a matrix that would, instead of having 2, 3, and 0, 5, it would be and 25. Very good. Okay, so that's simple. That's called scalar multiplication. I don't think you need to remember the word scalar, but that's what it is. This is called a scale factor. You just scaled it up to 5 times bigger than it was. Get that? All right, so that was simple multiplication for him. Now, don't think we need... Oh, man. Hey, when that happens, hold on just a second here. Yeah, there's a glitch in the matrix. Oh, great. Come on. Okay. So, you can make a shape using a matrix. In the old days of video games, you had to tell the computer like what area to shade in to like make the little guy. Okay? And you could tell them with just a simple matrix of numbers. This is like points. I want you to look at this shape, and you see this point right here? Would you agree that that's 1, 2? Do you see where that is in the matrix? So that implies that this is a what value? An x value, and that's a y value. So these are all x's, and these are all y's. Then you can't, then you're not doing a normal graph. If the question was asked, what if there were 3, like there was another row, like 5, 7, and 12, and negative 11. That could be the z-axis. You can do 3-dimensional graphing. That's where it goes over, and then up, and then towards you or away from you. Like when you get into this point, you go over, and then you go up, and then this point can either come out at you, like in a 3D movie, come jump out at you a distance, or go away from you. That's the 3rd dimension. The 4th dimension, Einstein theorized, was time. So anyway, there are 3 dimensions that you can picture. Tomorrow you're going to learn how to do computations, which is basically multiplying them, so you can move graphs over and stuff. So here is stuff I'd expect you to be able to do. If you graphed this triangle, you'd know it was, that's an x, that's a y, so the point -3, 2 is on here. I'm going to just drag this over, and I bet you if I line this up so that I have this at -3 and up 2 right there, then I bet all the points line up nice. Do you see how this one's 1, 3, and that's point B there? You get that? All right. So then what if I wanted to take this little matrix, which just drew me a little triangle, and I wanted to make everything move 3 spots to the left? 1, 2. Good guess, but it's not counterintuitive this time. Matrices are more intuitive. So if I wanted to make this whole thing move to the left, I could add. You always do add if you're starting the problem. And then you put numbers in here, 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 and here. That will make everything go to the left. Now you tell me, which should I mess with, the x's or the y's? The x's. So the x numbers were on top. So the y's I don't want to even mess with. So I'm going to add 0 to all of them. You get how I did? I don't want to change my y's. I just want to make the whole thing move to the left. So I want to take and add -3 to each of my x values. Now, I know some of you are thinking, well, wasn't +3 to move it to the left? That was when they were inside of parentheses. I know this is a matrix, but you have to trust me, matrices, you don't have to do counterintuitive. So if I wanted to go to the left 3, it should be -3. All right, so when I do that, I get new points. I just have to take this, put it with that, and I would get negative 6. Put this, put it with that, and I get 2. Take this, put it with that, and I get negative 2. This, put it with that, and I get 3. And the last one, I'll do with black, is 2 goes with the negative 3, makes negative 1. And negative 2 going with the 0 makes negative 2. There. So I got my new matrix. Those are the points that make up this blue one right here. Like, let's just check this spot right here. That would be at negative 1, negative 2, and that must be that point right there. See? Okay, so sometimes your matrices can be pictures. They can be like seating charts. They can be like rows and columns of data. Those are matrices, and you're putting numbers into a matrix. Yes? Could you have changed this to a minus and changed all of these to the opposite sign? Yes, but that would be a little more confusing, at least to a math teacher. I would prefer to leave it the way we have it. Could have done it the other way, though. Okay, application. Here is a typical problem. All it is it's a graph of those points, and that means this is a matrix. Okay, let's say that I asked you to move this whole thing 1 to the right and down 2. I would ask this: what matrix should I add to the first matrix to make that happen? 1, 1, 1. That's, you're moving it which way? The right, because those are the x numbers. And then down 2, what would I do? Minus 2, minus 2. Good. All right, so that's the intermediary matrix, and then the final answer matrix would be all the new points that I should graph. And that would be this going with this, which makes negative 4, and then this goes with this, makes 1. This goes with this, makes 3. This goes with this, makes 4, right? And this goes with this, makes, and lastly, that goes with that. There we go. If I graphed those, I would get my new triangle. All right, I think you get the idea how you could use it for a picture. That's enough of that. There are some flips that you need to know how to do. If I wanted to make my picture flip over the x-axis, we're just going to try to keep it simple and say, if I wanted to just flip this point over the x-axis, that would need to go down here. It's up 6, so now it needs to go down 6. And yes, it involves a multiplying by negative 1. What's my new point? What comma what? 2 comma negative 6. What got multiplied, the x or the y? So when you're going over the x-axis, it's the y's that get multiplied by negative 1. So to go over, write this in your notes, x-axis, y gets multiplied by negative 1. And that'll be really easy then to remember to go over the y-axis. You take the x and multiply by negative 1. Now, what about going over the line y equals x? All right, what on earth are you talking about, server? Well, if you want to flip it, but instead of flipping it across an axis, you flip it across a diagonal line like that. If I want to flip it across that line, then it looks kind of like this, and I'm going to keep moving it around until you guys think that I'm in. Should I go right, left, up, down? Where should I be going? Down. Back up. Right there. That's right. That's right. It's flipped over that line. Now let's talk about what points we have now. This point right here is 6 comma 2. Do you notice it used to be 2 comma 6? And this point right here is at negative 2, negative 4. Negative 2, negative 4. And it used to be negative 4, negative 2. So you just switch them around, right? So this is totally different. These two, you just multiply all the y's by negative 1. This one, you'd multiply all the x's by -1. This one, you switch the x's and y's. Okay, so if the matrix used to be this, 2, 3, 4, 5, 6, 7, you'd flip them around, and it would turn into 3, 2, 5, 4, and what? 7, 6. All right, that changed all the x's into y's and all the y's into x's. All right, that's what you need to know for today, and it's about lunchtime.